Okay, so I started a video for example number 4, and in the middle of it, one of my devices started speaking to me. I don't know, I think maybe I accidentally said a word that sounded like Alexa. I have no idea. Anyway, so my graph is already set up, but I'll redo the problem with you. So we have y equals 3x and y equals x squared, and we want to generate it around the vertical line x equals -3. So you'll notice this is a multiple choice question, no calculator necessary because we're not evaluating. Already we can throw out a and b. Now you'll notice a has a squared, but it doesn't square the outside radius minus the inside radius. So this is not a correct setup. Here you'll notice there's no squared at all, so we're not even finding volume of something. It looks like it's between C and D, so you'll notice the only difference between C and D is a +3 inside each of the radii. So that is probably going to be your best guess. So, let's hope that perhaps if you're taking the AP test, you get a problem like this, and you're running out of time, you can just use process of elimination. You wouldn't even have to set it up. However, let's practice setting it up. So go ahead and pause the video and try it on your own first. And if you don't feel confident yet, you can just keep watching. So go ahead and set up x and y axes. I set it up to the right of my paper so I can rotate it around this line, x equals -3. So here we have the straight line 3x, and we have x squared, which is curved. And if you forgot how to find intersection points, you would set x squared equal to 3x, and you would subtract 3x on both sides, that equals 0, factor out an x, you would get that it intersects at 0 and at 3. And so at 3, you can find the y value by plugging in 3 into either equation. You will get 9. So now we draw a vertical line at x equals 3. We take this graph and imagine it coming out of the paper similar to a slinky, hitting the paper again, going through my desk, going through the paper, coming around on the outside. So it creates this bowl shape where the bottom of a bowl is completely empty, a hole here. So a hole in the top, hole in the bottom. So it's really a solid object. I guess it's kind of like a bundt cake. If you know what a bundt cake is, it has a hole in the middle and it has that solid part on the outside. So we need to set up our slice. Because we are rotating around a vertical line, we need to set up a horizontal slice. So remember, in order to find the outside radius, we do need to take a look at the length from -3 all the way to the outside radius, and then we subtract the inside radius from -3 to the line so that we're just left with that piece. So we're going to take -3 and subtract away this outside piece. However, you'll notice both of them are solved for y. We need to have both of them in terms of x. So let's do that real quick. Again, when we usually take the square root of both sides, we have a positive and a negative. We don't care about the negative here because we are in the first quadrant. So this outside curve, instead of being x squared, will now be square root of y. And my inside radius will be given by -3 minus y over 3. Okay, so as a reminder, we do need to go from 0 to 9, not 0 to 3, because we're doing it with respect to y. You'll notice all of the answer choices have it from 0 to 9. Let's go ahead and take the outside radius, subtract it from the inside radius, put that in big brackets, dy. Now you'll notice this looks really close to answer D. It's not quite answer D. How they got answer D is they factored out a -1. So now it will be +3 plus square root of y. Then all of this is squared. And then similarly here, they factored out a -1 and then +3 plus y over 3 squared. But you'll notice when you take -1 and you square it, that turns into a +1, so it's like they were never there. So then you are left with answer choice D. So again, if you are on a time crunch on the AP Calculus exam, which you probably will, I remember I was, truthfully, just by looking at the answer choices, what I would do, I wouldn't even set any of this up. I would see that you need to revolve it around -3. So your best choice would be either A or D. You'll notice it has the 3, and then it has the curves with respect to y. And then I noticed that A has the squared on the outside instead of squaring each radius. So truthfully, this problem, hopefully, if you get something like this, make it a 20-second problem. Just look at your answer choices, see if you can pick it, and then move on. If you have time, you can come back and maybe set it up and see if you still agree. But honestly, when you have multiple choice problems, it's probably, especially ones where you don't have to evaluate, just make it a quick problem. Last example, we do need to evaluate, so this one's not going to be quite as quick. We have a figure, it is calculator active, so we have arctangent and pi over 4x. You'll notice that in this problem, it doesn't tell you which one is the curve above and which one is the curve below like it has in previous problems. However, I hope you notice that this is a line with slope pi over 4, which would probably be, it's a slope less than 1, maybe like 0.8. So that slope would be, that line would be here, the bottom piece. And then arctangent, it's okay if you don't remember what arctangent is off the top of your head. Just know that it's the one that's not a straight line. Okay, we would like to revolve this around the vertical line x equals 2. So here we are over at x equals 2. This is going to be similar to the example 3 on the previous page, where if you take this, again, like a slinky, rotate it around, goes through the paper, comes back around, you end up again with a similar shape as before. It's like a volcano where it's completely hollow on the inside. You just have the walls of the volcano. All right, we need to go ahead and draw our slice. Let's figure out the outside and the inside. So the outside would have gone from 2 all the way to arctangent. However, you'll notice we do need to have things with respect to y. So we need to solve for x. How to undo an arctangent? Well, you just take tangent. And then y equals pi over 4x. X is equal to 4 over pi y. So our outside radius, here's the OR, the inside radius, IR. Outside radius, you need to take 2, go all the way to arctangent, well now tangent. And then to get just this small sliver, we need to subtract 2 minus the line. Okay, let's set up using our formula, plug it into your graphing calculator. Again, we need to use y values, so I'm going to go from 0 up to pi over 4. My outside radius is 2 minus tangent y squared minus 2 minus 4 over pi y squared dy. Again, in your calculator, you can put in x's. Because we set it up with respect to y, we can change the variable just like we do with u substitution. Again, here remember to close the parenthesis on the x and then close the parenthesis again on the outside radius, square that. All right, there you have it, 0.431, which is D. All right, congratulations, you are done with calculus.